the Chicxulub crater in Mexico, in South Africa, in Germany, and he has also a very distinguished career in international organizations and societies. He has edited a very large number of special volumes and books, and he has also been interested in promoting international collaboration. So it's great having today this presentation by Christian. He has been widely recognized. He received the Barrington Medal by the Meteoritical Society and the Distinguished Service Awards from the Geological Society of America, the Meteoritical Society, and before I forget, and this is why I have this picture behind me, Christian was the director of the Museum of Natural History in Vienna. It's one of the best museums we have, and it's interesting, the mineralogical collection. He has a lot of rock samples and minerals from Mexico, which is very nice to see them. And Christian has also in Mexico for the drilling projects, the Chicxulub drilling projects. So thanks, Christian, and looking forward to see you soon in person. Bienvenidos al ciclo de conferencias, nuevamente bienvenidos, y el profesor Christian Koeber es un profesor emérito en la Universidad de Viena, miembro de la Academia de Ciencias en Austria, y uno de nuestros más distinguidos especialistas en cráteres de impacto, incluyendo el cráter Chicxulub en México. Realmente es un placer el poder contar con su presentación, y en la presentación va a examinar cómo distinguir cráteres de impacto y los peligros de los impactos, lo que esto representa. Estos son temas particularmente interesantes. Los cráteres de impacto caracterizan las superficies en el sistema solar de todos los cuerpos, siendo la Luna, que es nuestro más cercano, toda la superficie está cubierta de cráteres de impacto, pero la Tierra es un sistema muy dinámico y es muy difícil distinguir y reconocer a los cráteres de impacto. Bueno, vamos a ver que la Tierra tiene muy pocos cráteres de impacto reconocidos, menos del orden de unos 200, que 200 cráteres los podemos encontrar en una pequeña área en la Luna. The conference by Professor Koeber is about how to recognize impact craters and the danger of impact events. Most of the planetary surfaces in the solar system are characterized by impact craters. A very interesting example is the Moon is covered by impact craters. But in our planet, we have a very dynamic scene, and we have very few craters identified. And it has been extremely difficult to recognize impact craters. So Professor Koeber will explain how to identify these craters in the geological record, why it's so difficult to identify them, and also the danger the impact events pose to our society. Impacts deliver a high amount of energy in extremely short time scales. In just a few seconds, few minutes, a lot of energy is released, and this is one of the threats we have because there are many asteroids and cometary nuclei orbiting and eventually hitting our planet. So this combination will make a very interesting presentation. And we were just talking with Christian that this week is particularly is a special week because we have the anniversary of the nuclear bomb in Hiroshima and Nagasaki. So it's an example of a high release of energy, although the impacts present a much larger threat to our society. Pasamos la palabra a nuestro presidente de Fundación NAMI, perdón por extenderme un poco más, pero pues me da muchísimo gusto el tener esta presentación esta semana y reiniciar nuestro ciclo de conferencias. Muy bienvenidos todos.
Muchas gracias, Jaime. Thank you very much, Christian.
To the Earth, that meteorites do fall from the sky. Not that long. Next picture, please. Here we see some meteorites on the top and a little map on the bottom showing a meteorite fall that happened in a location in France, in Europe, in 1803. There were hundreds of meteorite pieces falling from the sky, and the French Academy of Sciences sent a researcher, shown here on the right side, Jean-Baptiste Biot, to investigate that fall of all these rocks that have fallen down. Because before that fall, meteorites have been noticed too, and people were thinking that they are concretions that form in the atmosphere, similar to hailstones maybe, or maybe they come from eruptions of some distant volcanoes where rocks are thrown out in the sky and then fall down again. In this case, this person, Biot, he interviewed many people, and what he did was what we call triangulation. He talked to people and they described where on the sky and from where to where they saw the fireball before it fell on the ground. And from that, he was able to calculate back from where actually did these rocks come. And they came from outside the Earth atmosphere. So in 1803, it was finally established that meteorites, in fact, are rocks from outer space. They're not formed in the Earth atmosphere. So this was new. And from then on, people had already collected meteorites, but now they were viewed very differently because now people realized they're messengers from outer space. They tell us something about what happens on other planets or between the planets. So, next picture, please. Many of you will have seen, I'm sorry, this is in German, the diagram, but I'm trying to explain it. Many of you will have seen fireballs or shooting stars in the sky. And what these are small pieces of extraterrestrial material that enters the Earth atmosphere at very high speed. We call the object before it enters the Earth atmosphere a meteoroid. And then when it enters the atmosphere, it does that so fast with many kilometers per second velocity that it causes the atmosphere through friction heating to start glowing. And this is what we see when we see a shooting star or a fireball, and it is called then a meteor. So this is, we don't see the object itself. They're too small. There may be some centimeters to meters across. And what we see happening is maybe in 100 kilometers altitude in the atmosphere. It is the friction heating of the atmosphere along the trajectory of that object when it goes through the atmosphere. And so it is slowed down by the atmosphere if it is a small object, and it may fall on the ground, whatever is left of it. And then we have a meteorite. So it's the same object. It's just called a meteoroid outside the atmosphere, a meteor in the atmosphere, and when it lands on the ground, it's a meteorite. And you may have seen that in museums somewhere, meteorites. So they're objects from outer space. Now, if, however, a meteorite is big, we're talking many, many meters, tens of meters, hundreds of meters, maybe even kilometers in size, they're fragments of an asteroid, and then they will not be slowed down in the atmosphere very much. They will hit the ground at high velocity, and they form a meteorite crater. That crater will be many times the diameter of the actual rock that hits the ground, 10, 20 times larger. That is huge, and it is because of the enormous energy that is being released during that impact. And Jaime mentioned it just before, on Earth, the only analog we have is atomic bomb explosions, because only they have that much energy in a very short time in a very small space that is being released. Now, what are